Now, we can use the law of sines to relate the lengths of constituent vectors A and B to that of a resultant C via the angles between all three vectors, such that sine alpha per A is equal to sine beta per B, which is equal to sine gamma per C, where A and B are our constituent vectors and C is our resultant. Gamma is the angle opposite C, alpha is the angle opposite A, and beta is the angle opposite B. You can click the hyperlink to read more. Additionally, we can relate the lengths of the constituent vectors to the lengths of the resultant by considering the angle between our two constituent vectors A and B, i.e. gamma, using the law of cosines, such that c squared is equal to a squared plus b squared minus 2ab cosine gamma. And you can click the hyperlink to read more. Now, in example 8, we want to find the magnitude of our resultant force R using x and y components of our constituent force vectors, as well as the law of cosines. And we want to find our interior angles using the law of sines. To begin, we will denote A as our 900.0 Newton force and B as our 600.0 Newton force. And we will find our x and y components as follows. The x component of our 900 Newton force is 900.0 times cosine 30.0 degrees. The y component is 900.0 newtons times sine 30.0 degrees. The x component of force of our 600 Newton force is 600.0 newtons times cosine 75.0 degrees, and the y component is 600.0 times 75.0 degrees. Now, our answer will be reported to 4 significant digits. That is, ax is equal to 779.4 newtons, and ay is equal to 450.0 newtons. Bx is equal to 155.3 newtons, and by is equal to 579.6 newtons. Therefore, the x component of our resultant is ax plus bx, which is 934.7 newtons, and ry, which is ay plus by, is equal to 1029 newtons. We can calculate our resultant as rx squared plus ry squared square rooted, which is 1390 newtons. Now, if we did this using the law of cosines, we can draw our vectors head to tail. And in this configuration, gamma is our complementary angle, which is taken as 135.0 degrees. Recalling our law of cosines, we have c squared is equal to a squared plus b squared minus 2ab cosine gamma. We'd have r squared, which is equal to 900.0 newton squared plus 600.0 newton squared minus 2 times 600.0 newtons times 900.0 newtons times the cosine of 135.0 degrees. And to solve for r, we take the square root of both sides of our equation, such that r is found to be 1390 newtons, which matches what we found via our x and y components. Lastly, we can use the law of sines to determine our interior angles. Recall from the law of sines that sine of alpha per 900.0 newtons would be equal to sine of beta per 600.0 newtons, which would be equal to sine of gamma, which is 135.0 degrees, per our resultant, 1390 newtons. And all terms are going to be represented with 4 significant digits, thus beta will be solved for in terms of 1 decimal place. So sine of beta per 600 newtons would be equal to sine of 135.0 degrees per 1390 newtons, and beta is equal to 17.8 degrees. Now we know all angles within a triangle have to sum to 180 degrees, so alpha would be 180 minus 135 minus 17.8 degrees.